I've let y'all work together absolutely every day of the semester except for Fridays. For once, I think I'm gonna let you practice yourself. So we gotta find a rock every time. Now, how can you have an eagle eye and spot exponential? Well, something weird happens with the y's, okay? Nothing weird's happening here. It's like they look like they could follow a pattern. So you have to find the change in y over x over every interval to really determine which is which. So plus 2. I should make you do. I'm gonna do the change in y over x every time. 2/3. Okay. Ooh, that's 4. Okay, 6. Now a lot of kids are like, well, that's out. Nope. That simplifies to 2/3. Okay. Okay, there's 4 again. Better go up 6. It's proportional. It's the same. Up 2. Up 3. Last one. 2. 3. Okay, that makes this linear. How do you know? Constant. This is A rock. Average rate of change. Constant A rock. And it's only got 1. No common ratio. Okay, this is where we could use any possible point. So like through equations, this is going to vary. But if you don't know how to do it, just pick an ordered pair. That's x1, y1. We know m's 2/3. So if we do point slope, not the original, x minus x1. The only way we can really check this question is if we, write it in slope, like go ahead and slope intercept it. This is the only way I can universally check. So 2/3 x, and then we got plus -6 over 3. Let's see if I did it right. 2/3 times -6, hey, that's -4. 2/3 times -6, that'd be -12 over 3, -4. If I choose x as -3, 2/3 times -3 is -2. Yeah, so it worked. So that's what I would do. Whatever ordered pair you pick, it should simplify to that. Okay, here we go. Down 6, up 3. Slope always has to be simplified. That simplifies to -2 over 1. Down 6, up 3. Okay, that's up 6 now. Okay, that's where it changed direction. So here it switches to positive 2 over 1. Okay, so that makes that makes this the vertex. Just make sure it's all throughout the interval or it's a trick question. Okay, so that means the vertex happened right here. Okay. And, okay, so the y's are going down as the x's are going up. Okay, so there is the vertex point, and then it opens up. So this is absolute value. How do you know? And there is a turning point at 6, -4. That's known as the vertex. So the common ratio is -2 or 2. Okay, it opens up. How do you know? Okay, so the slope is -2 from left to right of vertex. Then to the right of the vertex is +2/1, which opens up. A was greater than 1. I meant to put that here. Okay, the equation. Okay, A is, this is A. It's the change in y over x to the right of the vertex. So we got y equals A. Okay, the vertex is 6, -4. So x opposite h k. I'm going to sit back in my chair. Let's pull it closer to me so I can. I think I got to decide which classwork will get you most prepared for your quiz. I think day 2 will. Because or day 3 will. I think we might skip day 2. Okay. So let's look at A. Okay. This breaks down into 3/12 times x to the 5th over x to the 3rd times 1 over y squared. So that's the way you could break it up, is y squared's on the denominator. And 3/12 is 1/4. And this would be 5 minus 3 over 1. And that's just going to stay where it is. Okay, 5 minus 3 is 2. Now it's just multiply across time. X squared over 4y squared. Those are all positive exponents. Okay, one thing you could have done to help you is used my helpful handout. Okay, power to a power. Which part of this handout could you look at? Okay, power to a power. If I have a power to a power, exponent to an exponent, I multiply them. So let's look at this. Wait, I changed my mind. Okay, we're going to use the quotient property. So I simplify the inside first just to make it easier. So we're going to use the quotient power. And all of it's really technically happening over 1 up in the numerator. So here, okay, so that -2 is encased in parentheses. So it's -2 to the first. Okay, if I factor out 2 m's, I get m over m. They factor out. So they're gone. Okay, n to the third over n to the fourth would be n to the 3 minus 4. Anything divided by itself is 1. So that's why the m's are gone. And that's all over 1 to the third. Now I got -2 to the first, n to the -1. And we don't need to put it over 1. And so now we go to the third power. So I got -2 to the third, n to the -3. And it looks like I'm going to have to finish my answer up here. Okay, that means -2 times -2 times -2. So that's 4 times -2. It's -8 over 1 times. Okay, so that -8 stays where it is. N to the -3, we move it to the denominator. That's a tough one, dude. Okay, power to a power is multiply. So this is x to the first. Sorry, I need to get comfortable. Okay, that's x to the first. All whole numbers or variables have an exponent of 1. It's just not written. It's because you're multiplying x by itself once. So this one would be a great way. This one would be a great one to write it out. It's like write xy to the third times xy times xy times xy times xy times xy. But here, we're going to go x to the first times y to the third. I always write this step, x to the 1 times 4, y to the 1 times 4. So now I got x to the first times y to the third times x to the 4 times y to the 4th. So to show you what I'm doing x to the first times x to the 4th, y to the third times y to the 4th. Okay, when you multiply two powers with the same base, you add the exponents. If kids would show every step like I do, I think they'd do better on this. Why did we add there? Well, we're multiplying x by itself 5 times total. Then why'd I put 4? Let me use a pen that won't run. And now you're multiplying y by itself 7 whole times. I think when I do D, letter D, I think I'm going to write it out long style. I'll show you what I mean by that. It's like we could do 5ab times, okay, that's a complex base. So we're going to do times negative 2 a squared b to the first times negative 2 a squared b to the first. We're multiplying that base by itself 3 times. So this is more about why the rules work. Okay, and those are to the first. Alright, so now 5 times negative 2 times negative 2 times negative 2. Let's see, now we've got a to the first times a squared times a squared times a squared. Now I've got b to the first times b to the first times b to the first. Let's see if I can fit it. Okay, I'm doing this the long way. Okay, so that's negative 10. Negative 10 times negative 2 is 20 times negative 2, negative 40. And now we got a to the 1 plus 2 plus 2 plus 2. A to the 7th. You could do b to the first plus 1 plus 1 plus 1. We're adding up how many times we multiply b by itself. So b to the 4th. That's if you don't follow the power to a power law. Okay, if you follow the power to a power law, so you could do power to a power, which would be negative 2 to the 3rd, a to the 6th, b to the 3rd. That'd be negative 8. Then you add them. Whichever way works better for you. Okay, I don't feel like I gave us enough space to do this one. Okay. Here, let me draw some dividing lines. I did yesterday. Alright, that's that whole one. Okay. We're at 18 minutes. I ain't even got to the back. Okay, first thing I do, 12 divided by 4 is 3. So I just go ahead and take care of that. Now I'm doing x to the negative 4 squared. These aren't really good ones to write out. These aren't really the kind you would want to write out. Sorry, I'm trying to get comfortable. Okay, down here I got 1 times okay, so if I only have this much space, I'm going to show you the easy way. 3 stuck where it is. Okay, x to the negative 8, we're going to move that to the denominator. And down there we already have y. 1 times x to the 6. So if we move x to the negative 8 down, Okay, you can institute. So that leaves us 3 up top. One can go into the ether. Okay, now final steps for circling in. 6 plus 8. Three to the first. First. Okay, 3 and 6. They get to go to the head of the line. It's like Thanksgiving, and they're at my house. The senior go first to the smorgasbord of food. Okay, 3 times 6. Let's use the dot. Okay, here I got x to the negative 2 plus 1. I got y to the 1 plus negative 3. 2 powers with the same base, you add their exponents. Okay, this gives me 18 over 1 times x to the negative 1 over 1 times y to the negative 2 over 1. Okay, 18 stays up top. Okay, x to the negative 1, that moves to the bottom. And then that moves to the bottom. So final answer, 18 over x y squared. If I put the answer key on this tomorrow, I don't want y'all copying it. I just want you to try it. If you get stuck, copy it. Okay. This is that all the things we've been. Okay, so let's pick our inequality symbol. Okay, so sorry I'm making you nauseous. Let's see, can I make it clearer? That didn't help. Oh, it's because I'm zoomed in. Alright, there we go. Now let's adjust the... Way better. Okay. So dash above. So remember, like, up here would be greater than. Down here would be less than. So we know it's greater than. Okay, M. Fall 1, run 1. Y-intercept 0, 3. Equation, y is greater than negative x plus 3. Done. Okay. This is absolute value. So what do we need? What are some key points here? Okay, A is less than 0 because so it opens down. So that means A is going to be less than 0. We need to find the vertex. The vertex is negative 1, 4. AOS. What else do we need? Open A. Okay, we need A. To the right of the vertex. Down 1, run 1. A is negative 1. There's no inequality. So we go y equals a goes in front of the absolute value. Okay, we do the opposite of hk. So I'm doing the opposite of h here. And h is just the x of the vertex. We go x plus 1. And then we got plus 4. Okay. Let's say you have to write a piecewise definition one day. This is for advanced. This is advanced level stuff. I just want to reinforce, okay, the piecewise function. We go y equals. Okay, so this is the positive ray. Okay, so the positive ray has a change in y over change in x of 1. So it'd be 1 times, and we're talking about this piece only. We're only talking about this piece, which is linear. Okay, that's the only piece we're talking about. So, okay, we're going to use the vertex in our piecewise definitions. So you go y parentheses x plus 1 plus 4. Okay, and the x's here are less than or equal to -1. So for that piece of the function, so you always have to give the domain. And now let's talk about the negative ray. Okay, the slope is down 1, right 1. We already found that from the absolute value function. So you go -1. That stays the same. Except now we only use that piece when the x's are greater than -1. Okay, that's for advanced level stuff. That's how you break it up into the piecewise. Anytime I can go over piecewise, I will. I won't do it on the next one. Okay, so we got solid above. Okay, if it's solid and above, that's greater than or equal to. And this would be less than or equal to. Okay, vertex. Vertex is 5, -1. It opens down. Let's find A. Down 1, 2. Down 4. Right 5. So A is -4/5. It's always the first point to the right. What else do we need? A opens up. Vertex. Okay. This is the AOS, axis of symmetry. Okay, let's write our function. Y is greater than or equal to A, because it opens down, it's negative. X minus 5 minus 1. And I won't go over the piecewise definition. Okay, this is VUX. Vertical line, undefined slope, x equal equation. Okay, so this is dash left. So this side's less than, that side would be greater than. We're going less than. So you'd say x is less than, it's hitting the x-axis, it has an x-intercept of -1, 0. Okay, now the growth and decay function is actually on your it's actually on your reference sheet for the state test. So I'm at 30 minutes. I hope some of y'all don't use this to copy. Like, don't copy everything I'm writing. Okay, so I'm in the aims. I'm gonna try to push you on how to use the formulas to your advantage. Okay, so knowing whether it's growth or decay is kind of important. Okay, increases. So this is growth. Okay, the only way to get you used to the formula is to write it. So A is the initial amount like we've been doing. Okay, you do 1 plus R to the T power. Okay, so A is the initial amount, 1400. Okay, R has to be a decimal. Okay, how do I change 9% to a decimal? The definition of percent is per 100. So if I divide 9 by 2 zeros, R is going to be 0.09. Okay, so here's our equation. That initial amount goes in front. 1 plus 0.09 to the T. The growth factor is bigger than 1, so that's what makes it a growth. Now, let me pause it and get the calculator up. Okay, so let me zoom in. Okay, now it says use your exponential function to find out how much would be in your account after 25 years. So how do I enter that in my calculator? Okay, press 1400. How do you raise something to the power? Use the caret button. Me, I round to the nearest cent. Okay, B. Okay, this one is decay because it's decreasing. This is the decay function. Alright, so again, this one's different. It's y equals a 1 minus r to the t. So a, there's 1300. And this one, we'll talk about rounding. Okay, R has to be a percent, a decimal. So 1 divided by 100, that's 0.01. Okay, now let's put it together. Y equals, okay, we're going to do 1 minus 0.01 to the t. And you always have to simplify this part. Like 1 minus 0.01, or think about it. What's 100% minus 1%? 99%. So if that's less than 1, it's going to decay. Because if you take a fraction or a decimal to an exponent, it gets way smaller. So now we got to find 8 years later. So we're going to use t. We're going to use 8. All right, calculator. Okay. So you can't have 0.5 of a person. So you don't have enough for another person. So on this one, this is growth because it says increasing. R has to be a decimal, and percent means per 100. Now for me, I think 1 plus R to me is 1.06, so you could save yourself some time. Now we got to figure out 4 years. 12,000 increasing. The reason that one's there is we gotta preserve 100% of the original. 100% of the original is 12,000, and then we're adding a little bit. I gotta pick up the pace. .12. Okay, I just thought of a faster way I could help you. Okay. Alright, here's the easy button. Okay, so the formula has 1, and that means 100%. So it's going to give us 100% of 18,000, which is 18,000, minus 12%. So that's a faster way, is do 100% minus 12%, which a lot of kids can do that in their head, 88%. So that's the easy button. Ugh, that's not good. Okay, I clearly did not give y'all enough space to do this problem. Okay, it says rewrite in standard form. Let me get my notebook paper out. Okay, I didn't give you enough space, or myself. Okay, I'm done with the calculator. Bye, calculator. See you, old friend. Okay, I'm going to make this a separate answer key. Okay, I don't have enough space there. I think I can get it. Let's see. I think I can get this. What is standard form, you ask yourself? AX plus BY still distribute that across. Negative 12 over 30. I think I can get what I'm going to do is get rid of that 3 now. And writing this small is hurting my wrists. Alright. 3y plus 3 equals 6x over 3 minus 12. I don't want to ruin my good pen. Okay, so we gotta do a switcheroo. Subtract 2x. Subtract that 3. So negative 15 is good. I did make it. Oh, you can't see what I was doing. Sorry. I did make it. I got enough space on there. Okay, so a can't be negative. Multiply everything by negative 1 or just switch them all. I fit it. I can't believe I did that. And that one. Wow. That's impressive. Especially for somebody that has the worst handwriting that can't write small. Okay. Sorry. I was a little too impressed with myself. Alright. This one's harder. You distribute that across. You get plus 2/3. Okay, you want to multiply everything by 3. I'll do it now. I'll show all my steps. Negative 6 over 3x plus 6 over 3. I'm going to switch back to red. Okay, now add 2x, add 6. 2x plus 3y equals 8. Final answer. Okay, rewrite each in slope intercept. I went back and highlighted everything. Slope intercept. No point, no standard. No reason to get rid of the fraction. This one's a little tougher. Negative 3 over 2. Alright, don't flip out. Okay, so we need to make this a common denominator of 2. So when I add that, I'm going to add 6 halves. Add 6 halves. What I've been looking for to finish this course. 45 minutes. Jeez.